Today we're going to learn a little bit about how to solve an absolute value inequality. And this just is a range of values. An absolute value inequality is can always be turned into a compound inequality, an and statement or an or statement without any absolute value bars. So we are going to learn how to do that. And the first most important step is deciding, is it an and statement or an or statement? And you can think of it this way. If you just read from left to right and say, oh, the absolute value is less than 4, it's an and statement. When it's eating the number, it's an and statement. And if you read this from left to right, you would say the absolute value is greater. So you're going to say it's greater. So the one that has the or in it is the or statement, and the one that has the and in it is the and statement. And it's a good way to kind of keep track of it. So all absolute value inequalities that have a solution that are and will work like this. So take a look. Sorry, I'm getting ahead of myself. We're going to solve it using the tree branch method. Now, we're going to solve for two different inequalities. We're going to solve for x minus 7 is less than 4, and this is and, we had already said. And we are also going to solve for its opposite. And this is where we need to pay attention. We're going to hit this problem with a negative. We want to solve for a negative 4. And so that means we need to turn this symbol around. The real reason this works, and you do not need to write this down, is that you're solving for x minus 7 is less than 4, and you're solving for the opposite of this. And if we divided both sides by -1, which is what you should do, when you multiply or divide by -1, you would switch the direction, and that's why it does it. So basically, you're going to solve for the original and the opposite. And when you hit something with a -1, you need to flip the direction. So we're going to solve this problem, adding 7 to both sides. Great. X is less than 11. And add 7. X is greater than 3. Now, when you go to graph that, you would want to, I think it's easier to write it as a single statement, but you can choose to do it in two pieces. If we're going to write it as a single statement, though, I think this is what we should do. We've got our x in the middle. We're going to put our larger number down here. So that's 11. And look, it's eating the 11 here. And in this part, it's also eating the 11. And we're going to put our smaller number here, which is 3. And look, in this case, it's eating the x, and this inequality is eating the x. So we've set it up correctly. And we're going to shade in everything from 3 to 11. We're going to have open circles at 3 and at 11 and shade everything in between. So let's set up this or statement. And again, you have to write the words or it doesn't actually mean anything. X minus 7 is greater than 4, or we're going to solve for its opposite. So we're going to hit this with a -4. So I'm going to flip the direction of my sign. And I'm going to solve for both of those. So let's add 7 again to both sides. And we're going to get that x is greater than 11. Or, and add 7, x is less than 3. So that's the setup. Let's try one more tree method of solving just to see if we really know what's going on and graph. So take a quick moment, like it says, pause a moment and see if you can distinguish the and the or problem. So which one of these is an and which one is an or? This one, if I read it, x minus 2 is less than, so and I do solve this as one problem by doing this. For those of you who have seen that method and understand it, feel free to get on board. But we're going to teach the tree method, though for and, I never, ever, ever use it. So we're going to solve for x minus 2 is less than 5 And we also need to solve for x minus 2 is greater than negative 5. We have to solve for the opposite, so we have to flip the direction of the sign. So solve away. Let's use a different color to solve. We're going to add 2 to both sides. I'm just going to do it all at once. X is less than 7, and x is greater than negative 3. Well, if we go to here, we have our 0, 1, 2. Here's negative 3, and it's an open circle. And we're going to also go to 7, also open circle. And we're just going to color everything in between. That's what it means to be and. It's going to be, if it has a solution, it will work. I mean, how can you tell if an and statement doesn't have a solution? I'm not going to give you ones that don't. But in all honesty, if you did this and it doesn't make sense, like negative 5 is less than 5. True. This one will have a solution. But if it didn't work out to be something true, that would mean your and statement actually didn't have a solution. But we're not going to encounter those. So the last one, you hopefully distinguished that it was or. This one has the equal to, so we're going to color in our circles. And we are just going to quickly, x minus 2 is greater than or equal to 5, or, and we're going to solve again for its opposite. So when you do that, that's why everything switches. So what we're going to really write is x minus 2 is less than or equal to negative 5. And you're going to solve that. Let's add 2 to all sides. X is greater than or equal to 7, or x is less than or equal to negative 3. So we're going to find those two spots again. Here is negative 3, color it in. Here is 7, color it in. And x is all the numbers greater than 7 and all the numbers smaller than negative 3. And that's what we get. What I realize I failed to mention is step 1, isolate the absolute value, is still the first thing you must do, and then determine if it's and or. Happy solving!